Hello everyone, this is Ryan, your physics teacher. In this video tutorial, we're going to discuss the basic concepts of vectors and how to add them using the graphical method and the analytical method. For the graphical method, we will introduce two specific methods. The first one is the polygon method, followed by the parallelogram method. For the analytical method, we will then introduce the concept of unit vectors. Let us begin. First of all, let us distinguish a scalar quantity from a vector quantity. A scalar quantity is a quantity that only has magnitude. On the other hand, a vector quantity is a quantity that has both magnitude and direction. Let us look at some specific examples. Some examples of scalar quantities are mass, energy, and time. So it doesn't make sense to say 2 kilograms to the north or 2 kilograms east because mass doesn't have a direction. On the other hand, some quantities like force, torque, electric field, and magnetic field have direction, and they are called vector quantities. Some scalar quantities can become vector quantities if you add the direction. For example, distance is a scalar quantity, but if you add the direction, it becomes displacement, which is a vector quantity. The same is true for the case of speed and velocity. Vectors are normally plotted on a Cartesian plane. It could be a two-dimensional Cartesian plane or three-dimensional using arrows. I show here an illustration of an arrow. I'm sure that you are familiar with this. It has a head and a tail. Let us consider a vector A that I plot in an XY Cartesian plane. Take note that the symbol that we use for a vector has an arrow on top of the letter, such as vector A, B, and C in this figure. If we consider these three vectors shown on the screen, you see that vectors A and B have the same length. So they have the same magnitude. In symbols, we say the magnitude of A is equal to the magnitude of B. On the other hand, for the case of vector C as compared to vector A, you have seen that while the lengths of the arrows are the same, so they have the same magnitude, the directions are opposite. So we can write vector A equal to negative of vector C. The negative sign means that they have opposite direction, but we can equate them because they have the same magnitude. So the magnitude of A is equal to the magnitude of C. It is important that we know how to name vectors properly. And there are several ways of doing this. Let us consider a vector plotted on an xy Cartesian plane. Say it makes an angle of 45 degrees with respect to the positive x-axis, and the magnitude is 30 newtons. So this is a force vector. There are several ways of naming this. We can say this is 30 newtons, 45 degrees. If we don't say anything about the angle, it automatically means that it is measured from the positive x-axis. So 30 newtons, 45 degrees. Now, it could also be northeast, where east corresponds to positive x, north corresponds to positive y, or 45 degrees north of east, or negative 315 degrees if we measure the angle from the positive x-axis clockwise. Let us have another example. Suppose we have a vector that makes an angle of 30 degrees with respect to the positive x-axis clockwise. The magnitude is 60 newtons. So we can report this as 60 newtons, negative 30 degrees, or 60 newtons, 330 degrees. So the positive sign for the angle means that the rotation is counterclockwise, or 30 degrees south of east. The addition of scalar quantities is simple and straightforward. You simply have to add the magnitudes. For example, if you want to add the mass of different objects, you simply have to add them the usual way, like 2 kilograms equal plus 3 kilograms plus 4 kilograms. That's equal to 9 kilograms. On the other hand, for the case of vector addition, it's a little bit more complicated than that because you have to consider not only the magnitude but also the direction. We have several ways of doing it. The first one is using the graphical method, and under it, there is a polygon method and parallelogram method. There's also another way called the analytical method. This is where you're going to use your scientific calculator. And in this discussion of the analytical method, we will also introduce the concept of unit vectors. Let us start with the polygon method. Suppose we want to add two vectors, vectors A and B. So in the polygon method, what we do is we connect uh, the vectors as follows. So we connect the tail of the second vector to the head of the first vector. That is why we also call this the head-to-tail method. The resultant vector is given by vector C. Let us have an example to make this clearer in our mind. Displacement is a vector quantity that describes the change in the body's position. For example, suppose you walk from your house to with the following displacements. So I show this situation in this figure. First, you walk 10 meters to the east. Then after that, you walk 5 meters to the north. So take note that the length of the arrow for 5 meters is half of that for 10 meters. And finally, you walk 5 meters to the west. Again, it is important that you take note of the length of the arrows as well as their direction. So we construct the resultant displacement by connecting the initial position and the final position. As you have noticed, we have actually constructed a polygon. That is why this is called the polygon method. Now, I will walk you through the steps that you need to do in order to add these vectors using the polygon method. It is important that you define the scale that you will use in adding these vectors and using the ruler, protractor, and your graphing paper. So you define the scale. One convenient choice is 1 centimeter equal to 1 meter. That's the first step. The next step is to plot it on the Cartesian plane. The first vector is vector, so we can call it d sub 1 with an arrow on top to denote that it is a displacement. So please take note of how I plotted these three vectors on the xy plane. The tail of the first vector is at the origin, and we plotted the next vectors successively, head to tail style. Next step is to construct the resultant vector by drawing an arrow from the origin to the head of the last vector, just like what we did earlier in our illustration. So I show it here. We can denote this with symbol d sub r with an arrow on top. So that is the resultant vector. The fourth step is to measure the length of the resultant vector using your ruler. And also, you measure the angle using your protractor. If you do it properly, you should be able to get the following values. The length of the arrow should be 7.1 centimeters and the direction is 45 degrees. Take note that this is not the final answer because these are just measurements on your graphing paper. So the final answer can be obtained using the scale. 7.1 centimeters is equal to 7.1 meters using our scale, and the direction is 45 degrees. So the final answer is written here on the screen. 45 degrees, take note, is the same as northeast. The next method is called the parallelogram method. From the name of the method, what you do is you construct a parallelogram. So suppose you add two vectors, A and B. What you do is you construct or you write dash lines that are parallel to the two vectors. The resultant vector here is denoted by symbol C. Take note that you connected the tails of the two vectors. That is why this method is also known as the tail-to-tail method. Let us have an example. Force is a vector quantity that uses Newton, denoted by symbol capital N, as the unit. Suppose a force of 10 newtons is applied horizontally to a block. Also, another force is exerted on it with a direction of 30 degrees above the horizontal. Determine the resultant force on the block using the parallelogram method. To visualize the situation, I have drawn a figure as shown on the screen. The first force is directed horizontally, while the second force is directed at an angle of 30 degrees with respect to the horizontal. In solving this problem, just like what you did for in parallelogram method, you need to use these materials: ruler, protractor, and graphing paper. The first step, again, just like what you did for the case of the polygon method, you choose the scale. One convenient choice here is 1 centimeter on your graphing paper corresponds to 1 Newton in the problem. That is the first step. The next step is to draw a Cartesian plane, xy. And of course, plot the two vectors on the plane. Now take note of the way I will plot these two vectors on our Cartesian plane. We're going to plot this tail to tail, not in the same way as we did for the polygon method wherein we plotted it head to tail. This is our xy Cartesian plane. The first vector, vector f1, is shown on the screen. For the second vector, instead of connecting the tail of the second vector to the head of the first one, what we do is we put the tail of the second vector also at the origin. The next step is to draw two dash lines that are parallel to both vectors f1 and f2, making a parallelogram. That is what I am doing now here, as you could see on the screen. The first dash line is parallel to f1, while the second dash line is parallel to f2. The next step is to draw the resultant vector. The resultant vector can be drawn by connecting the origin and the point of intersection of the two dash lines. So it is essentially the diagonal of a parallelogram. For clarity, I will change the color of the resultant vector. I am now using green. So the resultant vector is denoted by symbol f sub r, again with an arrow on top to denote the fact that it is a vector quantity. After drawing the resultant vector, you use your ruler and protractor to measure the length of the arrow that corresponds to the resultant vector, as well as the angle that it makes with the positive x-axis. But that is not the final answer. So in order to find the final answer, you use the scale. So using the scale, you see that the resultant vector or the resultant force vector is 14.6 newtons. The direction is 10 degrees. The next method that we will discuss is called the analytical method. This is where you're going to use a scientific calculator. So let us consider a two-dimensional Cartesian plane with components x and y. I plot here a vector denoted by symbol A, vector that makes an angle theta with respect to the positive x-axis. So take note that this vector has two components, the x component and the y component, as shown by the projection of this vector on the x and y axis. This vector can be written in the form of a polar coordinate. So it has magnitude a comma theta, or rectangular coordinate ax comma ay. The first thing that we're going to do is to find the components of this vector using what you have learned from trigonometry. The x component of vector a is equal to a cosine theta, while the y component is a sine theta. Recall the different ratios that you can write in a right triangle using sine, cosine, and tangent. Let us have an example. Suppose you have vector A equal to 14 meters, 30 degrees. The magnitude is 14 meters. The direction is 30 degrees with respect to the positive x-axis. Find the x and y components of vector A. So we simply have to write ax equal to a cosine theta. Substituting the values, you will find that ax is equal to 12 meters. Likewise, for the y component of vector A, that is equal to a times sine theta, or 14 meters times sine of 30 degrees. The result is 7 meters. So that is a very simple way of finding the components of a vector. What about the angle theta that it makes with the positive x-axis? So what I'm doing here is I have shown here the vector again with the components ax and ay. Take note that we are actually looking at the right triangle. So using the Pythagorean theorem, the magnitude of vector A is equal to the square root of the sum of the squares of the two sides, ax and ay. So for angle theta, we write tangent theta equal to ay over ax, or the ratio of the opposite and adjacent sides with respect to the angle. So now that you know how to find the components of the vector and how to use these components to find its magnitude and direction with respect to the positive x-axis, let us now discuss how to add vectors using the analytical method. Suppose we want to add two vectors, A and B. This is vector A, and I plot here the next vector, vector B. Recall from the polygon method that we can connect them head to tail, just like what I've shown in this figure, and the resultant vector can be constructed by connecting the origin and the head of the last vector. So the resultant vector has components Rx and Ry. As you could see in this figure, vectors A and B also have components AX and BX, and they also have Y components AY and BY. Sorry, there's a mistake in the figure, so it should be AY and BY. So here you could see that Rx is equal to the sum of the x components of vectors A and B. Likewise, for the y component of the resultant vector, it is also just the sum of the y components of vectors A and B. Let us have an example. The following are three displacement vectors. Vector A has magnitude of 10 meters, direction is 30 degrees. Vector B is 5 meters north. Vector C is 12 meters, 40 degrees east of north. Add these displacement vectors to find the resultant displacement. So what we do first is we draw a two-dimensional Cartesian plane and we plot these three vectors. Vector A makes an angle of 30 degrees with respect to the positive x-axis as shown in the figure. Vector B is also shown in this figure. The direction is north, so that coincides with the y-axis. Vector C, on the other hand, has a direction of 40 degrees east of north. So the reference would be north, which is the y-axis, positive y-axis. Then you measure the angle to the east or going towards the positive x-axis. Now, you see that in this problem, the angles are given, or the directions are given in different ways, right? So it is convenient to write the directions of these vectors in a similar way. So we can do this by writing the vectors or the angles of the vectors with respect to the positive x-axis. So here you see that the direction of vector A is 30 degrees. For vector B, it's 90 degrees. And for vector C is 50 degrees with respect to the positive x-axis. The next step is to find the x and y components of the three vectors. Remember that our approach here is to find the components, and then we add the similar components to find the components of the resultant. So these are the x and y components of vector A. Similarly, for vector B, we just use the same equation, magnitude of the vector times cosine theta for the x component. For the y component, we use the sine function. For the x component of vector B, we take note that it is equal to 0 because vector B is directed to the north, so it doesn't have x component, it is entirely y. So for vector C, we do the same thing. We use the cosine function for the x component and the sine function for the y component. We just have to substitute the values and use your intelligent scientific calculator. So now that we have the x and y components of all the given vectors, we simply have to add the x components of all these vectors to find the x component of the resultant vector. And we do the same for the y component of the resultant vector. So here, the x component of the resultant is equal to ax plus bx plus cx, which is equal to 16.4 meters. For the y component, again, we simply need to add the y components of the three vectors. The result is 19.2 meters. In my class, I normally ask my students to construct a table that summarizes the results so that we can clearly see the values of the x and y components of the vectors and how they relate to the x and y components of the resultant vector. So in this table, I put here the magnitude of the vector, the angle that it makes with the positive x-axis, the computed x component, and y component as well. So we do that for the given vectors A, B, and C. Then for the resultant vector, we add all the x components. So that is Rx, or the x component of the resultant. Again, that is equal to 16.4 meters. For the y component, we just have to add all the y components, and the result is 19.2 meters. Now, these are just the x and y components of the resultant vector. To find the magnitude of the resultant vector, we use the Pythagorean theorem, as I have discussed earlier. You simply have to substitute the values of Rx and Ry. Then using your calculator, you should find 25.3 meters. That is the magnitude of the resultant. What about the direction? For the direction of the resultant, we take note that tangent of theta is equal to the y component over the x component. Substituting the values, you will find that theta is equal to 49.5 degrees. So now we have the magnitude and the direction of the resultant vector. So we can write the final answer like this: vector r with an arrow on top, again to denote that it is a vector quantity, is equal to that value. Now there's a mathematical device that you can use to easily add vectors if you know the components of the vectors. These are called unit vectors. From the word unit, the magnitude of these vectors is equal to 1, and their directions are mutually perpendicular to each other. Take note that x, y, and z axes are also mutually perpendicular. So the unit vector that points to the positive x-axis is denoted by symbol I hat. For positive y, it is j hat. For positive z, it is k hat. Let us see how we can write the components of a vector using the unit vectors. So suppose we have vector A that has two components. The x and y components are also vectors. The x component, ax, has magnitude of ax. The direction is to the positive x-axis. So we write I hat. For y component, it's ay j hat. So vector A can be written in component form as axi hat plus ayj hat. Let us see how we can use this form of a vector to add them. So suppose we have vector A that has three components, axi hat plus ayj hat plus azk hat. And we have another vector that also has three components, vector B. The resultant that we get by adding these two vectors is denoted by symbol R. So what we do is we simply add the two vectors in component form with unit vectors. So what we do is we simply add the components that have the same direction. In the direction of I hat, we add the x components, ax and bx. For j hat, we add the y components, ay and by, as well as, so that's the same for the z component as well. Let us look at this example. Let us solve this example. So suppose you have two vectors given by these equations. What is the resultant vector R? So the resultant vector has x components, ax plus bx. For y component, ay plus by. Now I forgot to write here the z component, which is az plus bz. You simply have to substitute the values, add all the x components together, the y components together, and the z components together, and the final answer is given by this equation. Let us have another example. Suppose vector A is the same as in the previous example, 2i hat minus 3j hat plus 5k hat. Vector B is I hat plus 4j hat plus 6k hat. Now what is vector C? If vector C is defined as 3a hat, 3a vector minus 2b vector. This is very simple. You just have to substitute the components of vectors A and B and distribute the coefficients 3 and 2. So if you do that, you will find that the final answer is the following. So this is the final answer. So that is the end of our tutorial in this video. I'll see you in the next one.